create a website from scratch in C++. We'll be using only the libraries that are part of the C++ standard library. Let's start by creating a cpp file, main.cpp. We'll need to include many header files. One of them is iostream for basic input and output. Then we need fstream for writing to files and reading from files. We need sstream, which is for writing to strings and reading from it. Then we also need the string library, hash include string. We need map for creating dictionary for the URL mappings. We want vector and also cstring. Then there is small difference for Windows and other operating system. So I will just check if the operating system is Windows, if def win32. If you are using Windows, you just need to write the code that comes inside this if statement, and if you are using any other operating system, you will just need to write the code that comes after this else block. I'm just writing both just to show you, because I don't know which operating system you will be using. Now if you are using Windows, we need to include winsock2, because that is a socket library for Windows, and for other operating system there is c/socket.h. We also need netinet/netinet /in.h, and we also need, I'm not sure whether unistd.h is required. If it is not needed, you just need you can remove that. I'm not sure whether it is needed or not. Now for Windows only, we need to include a lib file, if def again Windows 32, or we'll just write it inside this if statement. It's in here itself. Okay, we are including the library file of the winsock library. So pragma comment lib and just pass in the library, which is ws2_32.lib, and we need the semicolon. Semicolon is not needed, sorry. Now we'll create a function called run server, void run server, and also the main function int main. I will return 0, and in the main function we need to call the run server function. Now in the run server function, I will create variables for the host and port. The host will be a const character pointer type, and I want to run the server on the local host. If you want to run it on your IP address and all, you can just pass it in there. The local host is 127.0.01, and then we need the port also, which will be an integer, because we will not be changing its value. I use the const keyword, it's not necessary, and I set the port to 8080. You can use any port that you want. Now again, there is some differences for Windows and other operating system. Again, I'll check if the operating system is Windows, if win32, and else. And in the end, we also need endif. We need a variable called WSA data, which is a data type that the winsock library provides, and then we need to initialize winsock. So while initializing, we are also checking for the errors. So WSA startup, and then we need to specify the version that we are using in a make word, and we are passing in 2,2, which stands for 2.2, and then we need to pass in the pointer of WSA data, which we pass in by using the ampersand sign, which is for address of operator. If it's not equal to 0, then we will just print out the error. So if it is equal to 0, then it is successful. If it's not equal to 0, it has failed. So in that case, we'll just print out failed to initialize winsock. And we'll just get out of the function, that is return, because now there is no use in executing anything because initializing of the winsock failed. Now we need to create the socket, which is of the type socket. We are creating the socket for the server, so we name it server socket. We use the socket function, and we want the IPv4 address to be used. So AF inet, we want the TCP to be the protocol, and then 0, which will be for the protocol. Now we need to check if there is any error in creating the server socket. So if server socket is equal to invalid socket, in that case we'll just print out the error, failed to create socket. And again I will return. Before that I will just also clean up the WSA library, WSA cleanup. I will just copy this one and paste it in here also if the initialization also fails. Now for other operating system there is only very little difference, which is we'll just copy the same thing of creating the server socket. In here the data type of the socket is not a socket but it's an integer, and in here we are checking if it is equal to -1, then there is an error. Now we'll need to create a sock address structure to represent the server address. So sock address underscore in server address, and then we'll just fill in the value for the member variables. Server address dot sin family, and we want to use the IPv4, so we pass in AF inet. Then we want to set the host and the port for the server that we want. Server address dot sign address dot s underscore address, and it will be, we need to set it to our host itself, the local host. So we pass in inside this inet underscore address, we pass in the host variable. Similarly we also need to set the port. Again we server address dot sign underscore port, and we'll need to pass in the port inside the htons function. The htone converts the port number from host byte order to network byte order. Okay, there's a typo, should be port. Now we need to bind the server socket. So again we are checking for the error at the same time. If bind servers, not address, server socket, and then we need to pass in a struct pointer of sock address, struct sock underscore. Okay, there is no underscore between, sock address pointer, and then outside the parenthesis the pointer of our server address, and we also need one more argument, which is the size of the server address. And then if it's at equal to socket error, in that case we'll just print out the error, std c error, failed to bind socket. And again we'll just close the socket, close the server socket, and in that case if Windows, we'll just clean it up. So if def underscore win32, we'll just call the WSA cleanup function, and I will just end the if statement in here. In the end we'll just return, that is we'll just break out of the function. Now we need to listen for the incoming connections. That's the last thing that we do right now before rendering the HTML. So if again we are checking for the error at the same time, listening to the server socket, we want the server socket to listen for incoming connections, and we'll set the maximum length of the queue of pending connections to 1. That is, socket will accept at most 1 pending connection. Again we are checking if it is equal to socket underscore error. We'll just print out error listening or failed to listen. Failed to listen. In here again we need to close the socket, the server socket, and again if we are using Windows, we'll just copy the whole thing from here and paste. Now if there is no such a type socket error in other operating systems, then you can just use if socket error is equal to -1. I'm not sure whether there is the socket error in the other operating systems. Now outside of the listening, after listening we'll just print out, if everything works fine, we'll just print out server listening on host port, and we'll just end it std end line. Now for now everything is done. Let's just try to run it. Let's check whether it works or not. So in here g++, the name of the file is main.cpp, and then I want the executable to be named program, and in the end we need to include a library in Windows only, and it is the same in here, same ws2_32. For other operating system there is no such library, so we'll just run that to create the executable. Now the executable is created. Let's just run it /program, and now it is showing that server listening on the host port, which means everything, the binding, listening, everything works fine. The next step is creating the HTML and rendering that. Now let's create the HTML and render them. For that, on top I'm just going to create a map or dictionary. So std map, the first value will be a string, std string, and the second one will also be a string, again std string, and then I will just name it URL mappings, and we are just going to create two of them, and one of them, the first value will be a slash, which will be the URL or request path, and the next one is the path to the HTML file. So it will be in the template /index.html, and the second one is the about page, and the path to that one will be template /about.html. Now in here I'm going to create a folder called templates, and in that index.html and also about.html. In the about.html I'm just going to put about inside h1 tags, and in the index.html I'm just going to put home inside the h1 tag. Now after the map we need to put semicolon, don't forget that. Now we'll create a new function called void handle get request. There is small difference for Windows and other operating systems, so if def, or we'll do it later, you can just the other operating system users can also start coding right now itself. So void handle get _ request, and then we need to pass in socket client _ socket, and if you are using other operating system, instead of socket you need to pass in integer. I'm using Windows, so socket. Then the next argument will be the request path. It will be a string reference. We are passing it as a reference, passing the arguments as reference. It's a method of passing the arguments for function. Now in the function we will use the we'll check if the requested path is in the URL mappings. First I'm going to create a string type variable called response data, and now we'll check if the requested path is available in the URL mappings. If URL mappings dot find request path, and then if it finds until it reaches the end, if not URL mappings dot end, that is if it finds the request path in the URL mappings dictionary, then we will attempt to open the associated file. So std if stream file, we want to get the path to the file, and it will be the URL mappings second value. So when we pass in the request path, it gets this value. So if the request path is just a slash, then we get the path to the index.html. If it is /about, then we get the path to the about.html. Now we'll check if the file is successfully open. So if file is open, then we need to give some value to the response data variable. Response data will be equal to http:/1.1 200 ok /r/n/return carriage, and also new line. Content type will be text/html, and in the end we need /r/n/r/n. Now to this we need to append the contents of the HTML file. So in here I'm just going to put a plus sign, and we will append the content that we found in this file. So std string. We are converting the content of the file to the string. So std istream buff iterator character, and then pass in the file inside parentheses. And then we also need to do one more thing, which is std istream buffer, the same function itself, but this time we need to pass in an empty parenthesis. With this, we are appending the content of the HTML file to the response data after this http slash that after that string. Now in the end, I'm just going to close the file dot close. And what if we don't find the URL mappings in the the request path in the URL mappings? In that case, so else the response data will be equal to, I'm just going to copy the same thing, but this time in the end I'm just going to put an h1 tag in this itself. So h1, and then just print not found. Again, close the h1 tag. With this, we are managing the error also, 404 error also. I'm just passing the 404 also in here. h1 404 not found. Now we need to send the response data to the client. So we want to send to the client socket that we pass in as the argument. We want to send the response data itself, so we'll just convert it to a const character pointer using the cstring function. And then the next argument is the length or the size or the amount of characters that are there in the response data. We get that using the response data dot size function, and in the end there is the flags which we are just setting it to 0. And then we'll just close the socket, close socket. We are closing the client socket. Now this is for Windows. If you are using other operating system, in here we need to pass in integer. So I will just put it inside the if statement itself, because I said so that I will just be showing the code of every operating system. And in the end else, and also end if. And I'm just going to copy the code that in here, just paste it in there and just change this data type of the client socket to integer. That's all, no other change. Now we need to create one more function, which will be the parse request function. So in here it's not of an integer, it is a function that returns two data. We'll return it using a map itself. So std pair, it contains two strings, std string and again std string. One will be returning the method, or whether it is a get request, post request, etc. And the second one will be returning the path, the request path, whether it is the index.html or about.html, etc. So the name of the function will be parse request. It takes in the request data again, just as we did it for the get function, get request function. So just pass in that same argument. Now we will create a string stream to process the request data line by line. std I string stream, we'll just name it stream itself, and we want to do it for the request path data. Then we read the first line of the HTTP request containing the request method and path. std string line, and then we get that std get line, the stream, and pass in the line as the next argument. Then we create another string stream to process the first line, std I string stream. This time we'll name it line stream because it's for the first line, and pass in the line. Then we will tokenize the first line into individual words. We'll create a vector. This is why we are importing vector, and it stores many strings. So std string will be the data type, and then we'll just name it tokens. Then we create a single string which will be the token. Now we need to extract the tokens from the line. We use a while loop for that. While line stream, and this operator is used for extracting it, token. In here we are extracting the tokens from the line, and then into the tokens vector we are going to add the taken token to the tokens vector using the pushback function. Because the tokens is a vector, pushback is used to add an item to the end of the vector. Now we'll extract the request method and path from the tokens. Std string method, it will be equal to tokens dot size. If tokens dot size is greater than 1, and we put a question mark, and if it is greater than 1, then it will be equal to the first item of the tokens, otherwise it will be an empty string. Again we create another variable for the path also, std string path. It will be equal to if tokens dot size is greater than 0, that is if some tokens exists, then only there is a use in doing this. All right, so tokens 1, and if it is 0, that is if there is nothing in the tokens, if there is nothing in the tokens, then it will be an empty string. There is actually it's not very important to actually look for this condition, but what if the tokens is an empty string, then we will not understand what the problem is. And in the end we'll just return the make pair of, we'll return the pair of the method and path, just as the return type specifies in here. With this, the parse request function is also done. Now we will get into the main run server function, and in here I'm just going to create a try, and we will just continuously loop to handle incoming connections. And because there is a try block, we also need the catch blocks also. Outside in here, catch, we are going to catch for an exception, const std exception e, and then in that case I'm just going to print out exception, and then we'll just print what the exception is using the e dot what function. In the end I'm just going to end the line. Now there will be the chance for having unknown exceptions also. In that case I'm just going to again use the catch keyword and then pass in 3 dots. This is for unknown exceptions, and in the end we are going to print out unknown exception. I'm just going to end the line, and whatever happens in the end, we need to close the socket. Close socket, we need to close the server socket, and for Windows we need to also clean up. So if def win32 wsa cleanup, and end if. For other operating system there is no cleanup functions and all. Now we will get into the try block and do everything that is needed. In here we will create a while loop first, while true, and we will again initialize the structure to store the client address information. So address underscore in client underscore address. Earlier we created the server address, but this time we want the client address. It's a structure. Then we create the client a variable for storing the client address size, client address underscore size. It will be an integer, and we will just use the size of operator on the client address to check the size that it requires. Now we create a client socket, client socket, and we'll be accepting, we'll calling the accept function to accept incoming connection and obtain a new socket for communication. Again we'll just need to pass in the same arguments that we did for the bind function in here. So I'm just going to copy all the arguments apart from the server socket, and we just need to make some small changes. For first argument is the server socket itself. I just forgot it, because we need to connect to that specific socket, right? Server socket. This time it's not the server address that we need to pass in, we want to pass in the client address and the size of the client address. I mean we don't need any size of and all. This time we have created a variable, so we can just pass in that. If you haven't created a variable, then we will use the same thing that we did earlier, which was using the size of operator. Okay, now the socket is created. If you are using other operating system, again the data type is an integer, so I'll just in here take if def win32, else just copy the same line. In here it will be integer. Again we'll end the statement. We need to check for the errors also, right? In the Windows statement, I'm just going to check for the error. So if client socket is equal to invalid socket, in that case I'll just print out the error accepting connection. And we'll just return, or I mean we'll just continue, not return, because we just want to continue with the function. Just because a user can't accept the connection doesn't mean that we should stop the entire program. And for the other operating system, we'll just check if the client socket is equal to -1. In that case, we'll print error accepting connection. Now in the end, after every end, if I'm just going to print out the user who accepted the connection. std_cout accepted connection from, and then we pass in the client address dot sign underscore address. Get the address of the client and just print it out. std end line. I'm going to create a variable for the buffer, variable called buffer. It will be a character of 1024 bytes. So 1024 bytes can be transferred. And then another variable called bytes underscore received. It will be equal to, we'll call the receive function to receive the data. You want to receive from the client socket the buffer. Show to the buffer variable. Then the length of the buffer will be the size of the buffer itself. And then in the end we have one more, which is the flag, which will set it to 0 itself. Now again, I'll just check if the operating system is Windows. If Windows 32, also I'll create the else and the if blocks right now itself. In the Windows block, I will just check if the bytes received is equal to socket error other, or if it is equal to 0. So if bytes received is equal to socket error, or bytes received is equal to 0, if either of the conditions happen, then we will just print out that error receiving data and close the socket, or close the client socket. stdc error receiving data, and then we'll just end the line. We'll close the client socket, close socket, the client socket, and then we'll just continue. I'll just copy the same thing for the else statement for other operating systems, but this time the only change is in here we just check if the bytes received is equal to -1 or bytes received is equal to 0. We'll create a string variable called request data, request underscore data, and we need to pass in the buffer, and also the next argument is the allocator, which is the bytes received. Then we are not specifying the data type. Let the compiler specify the data type, because it may be it's a very long data type, right? Because yeah, it is a make pair. It is the data type that we get from the parse request function. It's a bit longer, so that's why I'm just passing in auto, so that the compiler just chooses the data type. The method should be inside square brackets, auto method and path, that's a pair, and we call the parse request function. We just need to pass in the request data as the argument, and then we'll just print out received. The method from the path, and in the end I'm just going to end the line. and then we'll call the handle get request function to render the HTML. We need to pass in two arguments. One of them is the client socket, and then also the request path, which will be the path that we get from the parse request function. Let's just run it. Let's compile it again. Okay, there is no error while compiling. Let's run the program. Server is listening. Let's go into the browser, search for it, and we have the HTML rendered. It is showing received get from the slash, which is the home page. Let's go into the about page, /about, and we are seeing the about, which means received get from about. Now let's look for something that is not existing, and in that case it is showing 404 not found, which means the get request is working fine. The next thing is handling the post request. Before handling the post request, let's make some changes to the HTML file. In the index.html, we'll just create a form. So I'll just click on shift 1 and the exclamation mark comes. Just click on enter to have a basic HTML code. So I'll just change the title, and now we'll just create an h1 tag again, just show home there, and then we'll create the form. The method will be set to post, and the action will be the same file itself. We are not going to redirect to any file, and in there I'm just going to show enter your name, and then inside an input we need a text input. So input type is equal to text, and the name is very important. I'm just going to give it to name because this input is to enter our name. The name should be remembered because we use this value to get the data. And we also need a button. So input type submit will specify that it's a button, and the value will be submit. Now I'll just copy the same thing and go into the about.html, paste it there, but this time the action will be /about itself. We are not going to redirect to any page. Now the HTML is done. Next is creating a function for the post request. So on top I'm just going to come and create the void handle post request function. So this function takes in 3 arguments. One of them is the client socket itself, socket client socket. Then we want the content length, the amount of data that we are passing, and then we also need the data that we need to post. So const std string at post data, post underscore data. Again we create a string stream to process the post line data line by line. Std I stream stream, I'll just name it stream. We need to pass in the post data. Then we create a line, a string to represent the line, std string line. I'll just copy this all from the parse request function. Okay, we just have this line, so we need not copy, we have already written that. And then we need the map also, which will be std string and std string itself, 2 std strings. I'll just name it parsed data. Now we process each line of the post data, splitting it into key value pairs. We use a while loop for that. So while std get line, then we need to pass in the stream and the line. We also need the ampersand. So what we are now, we will just find the position of the equal to separate key and value. I'll just use the data type size t. Position will be equal to line dot find the equal to sign. So inside single quotes pass in equal to. Now we'll just check if position not equal to std string and pos. In that case, we'll extract the key and value from the line and store them in the parsed data map. So std string key will be equal to line dot substring, that is get a part from the string, 0 and until the pose. We want to get the part of the string from the start until this position, and the value will be std string value will be equal to again the substring. We want to get the part of the string, but this time we want it from the position into the end. So pose plus 1. Then we are going to pass that as the two strings for the parsed data map. Parsed data key is equal to value, that is a dictionary. We are setting the key to this key and value of that specific key to the value variable. Now we'll extract the relevant information from the parsed data. Outside the while loop, I'm just going to come and std string name will be equal to parsed data, and we want to find the name. This name is the same variable that we pass in here. Now what we are doing in this while loop is we are converting the data into an easily extractable form. We are converting it into a dictionary format so that we can easily get the name from that. So this will be in some sort of other UTF-8 format and all. We convert it to a usable format. Now we'll consider the response data with a greeting using the extracted name. Std string response underscore data, and it will be equal to the same response data that we have in here. Just going to copy that, paste it in here, and in the next line I'm just going to append to the response data plus equals. I'm just going to pass in a greeting h1 hello, and then we'll also print out the name. There's a, we should use double quotes, I just forgot that, hello, and then we'll append to that the name, and also in then we need to close the h1 tag, so slash h1. Okay, now we are closing that. With this we'll be showing a greeting along with the response data itself. Now we are opening the file index.html std if stream file, just passing the path to the index.html template slash index.html. I mean, it should not be curly braces, and then we'll just check if the file is open. If file dot is open, if that is the case, then we'll just append to the response data plus equals the contents of the HTML file. Okay, I'm just going to come in here, just copy these two lines, I mean this one line, paste it in here. We are appending the content of the HTML file to the response data, and then we'll just close the file. And outside everything we need to send the data to the client socket. To send client socket, then we have the buffer, which will be the const character pointer of the response data. So response data dot c string to convert it to const character pointer. And we need to pass in the length or the amount of characters. The response data dot size, we will get that because each character is of 1 byte, and the flag will be 0, and then we'll just close the client socket. Okay, now this one is for Windows. There is very small change for the other operating system, which is just change the socket into integer. I'll just do that right now. If def underscore win32, and we'll do all this. And if you are using other operating system, else, and if I'm just going to copy the same thing, exact same thing, paste it in here, and this time change the data type of the client socket to integer. No other difference. Okay, now we need to make some changes to the get function, because in the post we are not passing the request data. We'll just need to make some changes in here. Actually, this one is not just for the get request, it is for both of the requests. but the get request is completely done in here. That's the only difference. So I just change the name of the function to handle underscore request from handle underscore get request, and in the server I'm just going to change the name when I'm calling it. In here it should be just handle request instead of handle get request. We'll come into the handle request function. We'll go on top into here, and we need to pass in two more arguments. One of them is the content length itself, in the content length, and also we need the same argument that we pass in for the post request, which will be a string post data. Okay, there is a typo, I guess. No, yeah, there is a typo, post data. Now inside this function, small change is we'll just check if we are doing a post request. If we are doing a post request, then we will just call the handle post request function. Otherwise we'll continue with all this. And for the else one also, I'm just going to paste the same thing. The extra parameters are added in here. The socket should be integer itself. Now in here I just check if we find the request path in URL mappings. And also one more thing that we need to check, if is the content length is not equal to 0. Not equal to 0, then that means we are doing post request. In that case, I'll just call the handle post request function, and we need to pass in the client socket. We need to pass in the content length and also the post data as the arguments. Otherwise we'll just handle the get request. I'm just going to put all of these inside the else block. Control X, paste it inside the else block. I will just add an indentation. Okay, now that's it. Now we'll just copy all of this code for the other operating systems also. Just paste it in here, and now that's also done. Now we'll get into the run server function. And after printing received method from, we'll do everything else in here. I'll create a variable for the content length variable and initialize it to 0. We also need the post data, which will be a string, std string post underscore data. And we check if the method is equal to post. If method is equal to post, then I'll create a size t variable, position variable just like we created in the handle post request function. We are going to find from the request data, find the /r/n/r/n, which comes before every actual HTML content. Now we check if the position is not equal to std string /npos, then we'll extract the headers and create a string stream for parsing. So std string headers is this value. Actually headers is this http, this value until in here. So this is the header and this one is the code for HTML. So we are getting the headers. We'll go into the run server function. Okay, headers is equal to request data. From the request data we need to filter out dot substring from 0 to the post istream or istring stream header stream headers underscore stream, and it will be the headers. We are extracting headers and creating a string stream. This string stream is for parsing the data headers. Then we again create another variable which will be just the header, unlike headers. Now we are iterating through the headers to find the content length. So while std get line, we need to pass in the headers stream, then we need to pass in the header and also /r to find the content length. a content length from the header. So if header dot find, if the header finds the content length string, because while creating the response data we pass in the content length, and we doesn't pass it, we pass the content type, right? The content length will be automatically done itself. We get the content length if it's not equal to std string pose. We store the data in the content length variable. It will be equal to std string to integer using the stoy function, header dot substring 16, and then we just break out of the while loop. And in the end, after the while loop, we get the post data. Post data will be equal to request data dot substring from the post onto the end. So post plus 1, post plus 4 actually, not 1. Post data is equal to request data dot substring. We are extracting the post data from the request body. Now in the end, along while the handle request function, we need to pass in the content length and also the post data. So if the post data is an empty string, then it will be a get request. If the content length is equal to 0, just like we initialize in here, then it will be a get request, otherwise it will be a post request. Now let's try that. We'll just close this server. Again we'll compile it. Now everything is working. Let's run it. Come into the browser, search the same thing again. The HTML is updated. Let's just type in some names, submit, and it is showing the hello name in here. Let's go into the about page, do the same thing, and it is showing the same thing, which means our post request is also complete. And with this, the website is complete. I hope you enjoyed it. If you learned anything new, please subscribe, because this took a lot of time to create this.